The Babylonians, an ancient civilization that flourished in Mesopotamia, present-day Iraq, left an indelible mark on human history with their advances in law, architecture, mathematics, and astronomy. This essay will explore three significant aspects of Babylonian culture: Hammurabi's Code, the Hanging Gardens, and their contributions to mathematics and astronomy. Hammurabi's Code. Hammurabi, the sixth king of the first Babylonian dynasty, ruled from 1792 BC to 1750 BC. He is most famous for Hammurabi's Code, one of the earliest and most comprehensive written legal codes in history. The origins and structure of the code. Hammurabi's Code was inscribed on a stele, a large stone monument, and placed in a public space so that all could see the laws governing their society. The code consists of 282 laws, covering a wide range of topics, including trade, labor, property, family, and criminal justice. These laws were designed to maintain order and justice in Babylonian society and reflect a sophisticated understanding of legal principles. The code is structured in a casuistic format, meaning it follows a conditional, if-then, pattern. For example, one of the laws states, if a man destroys the eye of another man, they shall destroy his eye. This principle of retribution, known as lex talionis or the law of retaliation, is a cornerstone of Hammurabi's legal system. Social and legal implications. Hammurabi's Code is notable for its emphasis on justice and fairness, albeit within the context of the social hierarchies of the time. The laws differentiated between various social classes, including free men, freedmen, and slaves, with different penalties applied depending on the perpetrator's and victim's status. For instance, if a free man injured another free man, the punishment would be more severe than if a slave committed the same offense. This stratification reflects the deeply ingrained social divisions of ancient Babylonian society. The code also addresses issues related to commerce and trade, essential aspects of Babylonian life. It includes laws regulating prices, wages, and commercial transactions, ensuring fair practices and protecting consumers. These regulations highlight the advanced state of the Babylonian economy and the importance of trade in their society, legacy and influence. Hammurabi's Code has had a lasting impact on legal thought and practice. It influenced subsequent legal systems in the region, including those of the Hittites and Assyrians. Its principles can also be seen in later legal traditions, such as the Mosaic Law of the ancient Hebrews and Roman law. Moreover, the stele bearing the code was rediscovered in 1901 by French archaeologists in Susa, Iran, and is now housed in the Louvre Museum in Paris. This discovery has provided valuable insights into the legal and social structures of ancient Mesopotamia, contributing to our understanding of early human civilization. The Hanging Gardens of Babylon. The Hanging Gardens of Babylon are one of the seven wonders of the ancient world, renowned for their extraordinary beauty and engineering marvels. Although their existence remains a subject of debate among historians, they are traditionally attributed to King Nebuchadnezzar II, who ruled Babylon from 605 BC to 562 BC. Description and construction. The Hanging Gardens were said to be a series of tiered gardens, containing a wide variety of trees, shrubs, and vines. These gardens were built on a grand terrace-like structure, which allowed the plants to cascade down the sides, creating the illusion of a green mountain. The construction of the gardens required advanced engineering techniques, particularly in the area of irrigation. According to ancient sources, the Babylonians used a system of pumps, channels, and cisterns to transport water from the Euphrates River to the top of the gardens. This method allowed them to sustain a lush, verdant landscape in the arid Mesopotamian climate. Historical accounts. The most detailed descriptions of the Hanging Gardens come from later Greek and Roman writers, such as Strabo and Philo of Byzantium. They describe the gardens as a paradise-like retreat, filled with exotic plants and flowers. These accounts, however, were written several centuries after the supposed construction of the gardens, leading some scholars to question their accuracy. There is also a lack of direct Babylonian documentation about the gardens. The absence of references in Babylonian texts and inscriptions has led some historians to speculate that the gardens might be a mythical or exaggerated account based on real, but less grandiose, garden constructions. Significance and legacy. Despite the uncertainties surrounding their existence, the Hanging Gardens symbolize the ingenuity and sophistication of Babylonian engineering and architecture. They reflect the Babylonians' ability to manipulate their environment and create artificial landscapes that inspired awe and admiration. The legend of the Hanging Gardens has also had a lasting impact on cultural and artistic traditions. They have been depicted in numerous works of art and literature, from ancient times to the present day. The idea of a lush, terrace garden has influenced garden design and urban planning throughout history. Advances in mathematics and astronomy. The Babylonians were pioneers in the fields of mathematics and astronomy, developing sophisticated techniques and concepts that laid the groundwork for future scientific advancements. Mathematics. Babylonian mathematics was highly advanced, particularly in the area of arithmetic and algebra. They used a sexagesimal, base 60, number system, which is still used today for measuring time and angles. This system allowed for complex calculations and the development of mathematical concepts that were far ahead of their time. One of the most remarkable achievements of Babylonian mathematics is the Plimpton 322 tablet, which dates to around 1800 BC. This clay tablet contains a list of Pythagorean triples, demonstrating that the Babylonians understood the Pythagorean theorem long before it was formally attributed to the Greek mathematician Pythagoras. The tablet also indicates that they had methods for solving quadratic equations and understood the concept of irrational numbers. The Babylonians also made significant contributions to the development of algebra. They used sophisticated techniques to solve linear and quadratic equations, employing methods that resemble those used in modern algebra. Their approach to problem solving was practical and applied, often motivated by real-world problems related to trade, agriculture, and construction. Astronomy. Babylonian astronomy was equally advanced, characterized by meticulous observation and detailed record-keeping. They observed the movements of celestial bodies and developed a complex understanding of the cycles of the moon, planets, and stars. One of the key contributions of Babylonian astronomy is the development of the zodiac. The Babylonians divided the sky into 12 sections, each associated with a specific constellation. This division allowed them to create a calendar system that was closely tied to astronomical events. The zodiac system they developed is still in use today in both astronomy and astrology. The Babylonians also excelled in predicting astronomical phenomena, such as lunar and solar eclipses. They used mathematical models to understand the regularity of these events, allowing them to make accurate predictions. Their observations and records of celestial events were passed down through generations and influenced later astronomers, including the Greeks and Persians. In addition to their observational skills, the Babylonians developed theoretical models to explain the movements of celestial bodies. They recognized that the planets followed regular paths across the sky and developed geometric models to describe their orbits. These models laid the foundation for later astronomical theories, including those of the Greek astronomer Claudius Ptolemy. The Babylonians' contributions to law, architecture, mathematics, and astronomy reflect the sophistication and ingenuity of their civilization. Hammurabi's code stands as a testament to their advanced legal principles and social organization. The Hanging Gardens, whether real or mythical, symbolize their engineering prowess and aesthetic sensibilities. Their advances in mathematics and astronomy laid the groundwork for future scientific developments, influencing cultures and civilizations for millennia. As we reflect on these achievements, it becomes clear that the Babylonians played a crucial role in shaping the course of human history. Their legacy continues to inspire and inform our understanding of the ancient world, demonstrating the enduring impact of their contributions to human knowledge and culture.